Hello and welcome to my digital poster presentation. This is Xizhong Chen from University of Cambridge. The topic of this presentation is about experimental and numerical analysis of the flow property of different lactose grades. So the flow property of a powder can be characterized by a ratio cell test. The flow function coefficient is defined by the ratio of the consolidation stress to the unconfined yield stress. In this project, we use the Schulze cell test, and we perform both experimental and DM simulation for the shear cell test process. So these are the shear cell results for different lactose grades. In the left are the lactose hair 100, which has the largest particle size. So we can see the light under 3 consolidation stress. The 3 lines collapse into one curve, and the bulk cohesion of these powders is nearly 0, which means that this is cohesive powders. In the right is the lactose hair 300. We can see that the shear stress largely depends on the pre-consolidation stress, and the bulk cohesion increase with the increase of the consolidation stress. To study the effect of the surface property on the flow of powders, our collaborators in Hertfordshire University use the wet decantation to produce clear lactose powders. So we can see that after decantations, fines are removed from the surface of particles, and the surface of particles become more smooth. So after decantation, the surface energy and the mean particle size change slightly. We then carry out shear cell tests for the decantation powders. We find that the flowability decreases after decantations, and the internal friction angle of particle is less sensitive to decantation. We also carry out the DM simulation for the shear cell process. To simulate fine and cohesive particle flows, the computational cost is usually very large. To speed up the DM simulation, we have developed a coarse-grained JKR contact model. The idea is that instead of tracking individual particles, we track a cluster of particles, so that the number of particles to be calculated is significantly reduced. By adjusting the material properties, we are able to develop a scaling node that not only can significantly reduce the computational cost, but also maintain the same simulation accuracy. So after calibrations, we can use the coarse-grained DM simulation to study different processes, like study the particle mixing in a rotating drum, coupled with CFD simulation to study the fluidization and treatment of the cohesive particle flows. So in conclusion, the shear stress of lactose powders depends on the particle size. The wet decantation will modify the surface property and change the powder flowabilities. After calibration, the DM simulation with a coarse-grained JKR model can be used to efficiently predict the cohesive particle flows. So thank you very much for your attention.